Algebra 2, Chapter 9, Section 6, Identifying Conic Sections. So I've sketched a couple of these out, but parabolas, circles, ellipses, and hyperbola are all called conic sections because you can take a cone, cut it with a plane, and you can see the shape that's left over is each one of the shapes. So that's a parabola right there. We have a circle on the top, and then an ellipse down on the bottom. And of course, you've got yourself hyperbolas on the last one. So that's the idea of where all these things come from. So that's one way you can make all of these shapes, and all of these shapes made this way are with these equations that we've been learning about. You know, the x squared plus y squared equals 7 for circle with center at 0 and radius the square root of 7. That's like every one of those equations we've worked with can be made by cutting one or two uh, cones, just like we see here in this image, which is kind of neat to think about. All right. So for any conic section, we have, it's kind of like a standard form. Notice first, before I read the whole thing, all of the coefficients are with capital letters. Um, They don't have to be, but we prefer when we have capital coefficients like that. That usually means whole numbers or whole integer values, right? Doesn't have to be, but that's the preferred way of writing it. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So if you have any um, equation written out in this format, and you particularly have to watch for A, B, and C. They're not all 0 at the same time. Because if A, B, and C are 0 at the same time, the only thing that's left over is linear. So we don't really, at least one of them has to be non-zero. It could be the C, it could be the A and the C. It doesn't really matter, but at least one of those things has got to be not 0. And if you're given an equation in that form, it can be rewritten as any of the ones we're familiar with: circles, parabolas, ellipse, or hyperbola. So that's what we're going to start with. We're going to start with something that's in standard form for a conic section. Uh, or we're going to write it in general form. We're going to put it in its standard form, whichever conic section it is. Then we're going to identify it either as parabola, circle, ellipse, or hyperbola. And the last thing we're going to do is graph it. So I have 16x squared and negative 128x. I'm just rearranging it so that the x's and the y's are near each other. And, to make my life a little bit easier, I'm going to add 144 to both sides. So I have 16x squared minus 128x plus something to complete the square. And already, based on seeing that there's an x squared and a y squared, I know it's not going to be a parabola. Plus, well, I guess I should do negative minus 25y squared, because that is a perfect square on its own, equals 144. All right. Let's go ahead and factor out 16. 128 divided by 16, I think that's 8. 128 divided by 16 is 8, yeah. Minus 8x plus something minus 25y squared equals 144 plus 16 times the thing that completes the square. Negative 8 divided by 2 squared is -4 squared, or 16. And 16 times 16 is 256. So I have 16 times x minus 4 squared minus 25y squared equals 144 plus 256 equals 400. All right, so at this point, even though it's not all the way done, there's a couple things that we can do. We notice that the coefficients here, the 16 and the -25, aren't the same, so that rules out the circle. If they were the same, that would mean that the stretching in the x and the y directions are the same amount, which would be a circle. That means we've either got an ellipse or a hyperbola. I notice one of the terms is negative. That's going to tell me it's a hyperbola. But let's confirm that before we write it out. And let's divide all the parts by 400. So how many times does 16 go into 400? 25. Okay, good. They're pretty nice with this, with our divisions. They usually match up. There we go. That is most definitely a hyperbola. Now we need to graph it. Well, let's think back to how we graphed a hyperbola. A squared is 25, which means a is 5. B squared is 16, which means b is 4. And my center is at +4 is 0. So I'm going to draw it with the blue dot. +4, 0. There's my center. And now, since it is an x squared that's positive, that means the transverse axis is horizontal. So I'm going to count left and right 5 points. 1, 2, 3, 4, 5. All right. That's my vertices. Now I can go, I'm going to do with these with blue dots here. Up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. There's my co-vertices. And of course, that also gives us our box. Probably should have made this graph a little bit bigger, but this is fine. And of course, our asymptotes go out through the corners from the center. All right. I'm just drawing it 1/4 at a time, just because it's easier to get the right slope that way with the way my pen works on the screen. All right, so there's my asymptotes. So my hyperbola is close to them, swoops down to the vertex, and then swoops back up and gets close to the asymptotes. Starts close, gets down to the vertex, and swoops close again to the other asymptote. And there is my hyperbola.